Aloha, my name is Matthew Hallstein. I'm from the Honolulu Community College, and the title of my project is Detecting the Spectral Difference in Phone and Tablet Displays. According to Statista, worldwide in 2019, 3.2 billion people owned a smartphone and 1.23 billion people owned a tablet device. With the increase in devices on the market, along with different marketing techniques used by companies to promote that their product emits the best color, how can we know for sure which product is really the best? Using a microcontroller and the SparkFun spectral sensor, the average amount of color that is emitted from different screens can be measured. My hypothesis? If the display types of different electronic screens are reset to their default setting, then a difference in the amount of color emitted from the screen will be measured between different models, possibly influenced by the quality of manufacturing by different companies and the constant advancement of technology. The four photos in the top right are the four different devices that I will be running my tests on. The top two are phones, the Samsung Galaxy 8 and the iPhone 10, and the bottom two are the iPad tablets, the 5th generation iPad and the Air 2 iPad. Materials for this project include the SparkFun Redboard and Spectral Sensor Kit, a computer with USB, which will serve as your power source for the Redboard, 2 iPads and 2 phones. Methods to connecting your sensor. So first you connect the spectral sensor to the Redboard, and then your Redboard to computer with the USB. Then on the Arduino application on your computer, under Libraries, SparkFun AS726, upload the basic readings test. This is an example code provided by SparkFun, and this is the exact code that I used when running my tests. And also, finally, check to make sure that the serial monitor baud rate is at 115200, otherwise your data will not show. And as for the test procedure, first, I reset the test device settings to its default factory settings. Then I measured the desired viewing distance from screen to sensor. I displayed the test image on screen and turned off all the lights, eliminating the possible factors of background color interfering with my data. And finally, I uploaded the code to my Redboard and held the sensor steady in the center of the screen for 20 to 30 seconds. One thing to note is the only difference in test procedures between the phones and iPad tablets are the distance at which I held the sensor from the screen. So after doing some research, I found that the phone is best viewed from 12 to 14 inches from your face, so I held the sensor 12 inches from the screen. And as for the iPads and tablets, they are best viewed 16 to 20 inches from your face, so I held the sensor 16 inches from the screen. And the top right image is my sensor hooked up to the Redboard, and the bottom right image is the image I used for testing. One thing to note before talking about my data is that my sensor was not officially calibrated because of the lack of equipment, and I did not want to spend a bunch of money on professional equipment and tools needed for the calibration process. So my data values may not be exact, but they are consistent throughout my tests and are the best given my circumstances. So the sensor measures the 6 colors, violet, blue, green, yellow, orange, red, included in the visible light spectrum. The visible light spectrum is a portion of the electromagnetic spectrum that is visible to the human eye. In creating the chart, I averaged out the total irradiance values for each of the 6 colors. Irradiance is when any kind of radiation, in this case electromagnetic waves, fall on a surface. The sensor uses the unit measurement of microwatts per centimeter squared. And the 5th generation iPad is in the darker green, and the iPad Air 2 is in the lighter green. So from just quickly going over the data, you can see that the 5th generation iPad emitted all 6 colors the strongest, mainly in green and yellow, but also relatively strong in violet and blue, and it drops off towards orange and red, which were the lowest 2 colors. And you can also see a trend in both iPads from left to right that they both follow. This is the data chart comparing the 2 phones, the iPhone X in the darker blue and the Samsung Galaxy 8 in the lighter blue. Again, quickly just going over the data, you can see that the iPhone X emitted color the strongest compared to the Samsung Galaxy 8. And both phones surprisingly were not high in emitting yellow and green, but majority blue, which was something that was interesting when analyzing the data. In conclusion from the test results, there is a spectral difference between the types of devices tested. The 5th generation iPad emitted the highest irradiance averages for all 6 colors across all devices, while the Samsung Galaxy 8 emitted the lowest irradiance averages. Both iPads emitted the colors green and yellow the strongest, while both phones emitted blue the strongest. The Apple products proved to emit the best color on screen while compared to the Samsung. Future plans for this project include calibrating the sensor in a professional lab setting. This way I can determine how accurate my test values were. And I wonder that if in a professional calibrated setting, how much would my values change if they do, and would I get different color readings from the products? Also, I would like to run more tests. This time, instead of using a majority green image, I would like to use a plain white screen, which is a more neutral color image. And this would also help me to conclude which screen emits color the best, as white is a combination of all colors. I would also, since I did compare majority Apple products against Samsung, I would like to run more tests with a Samsung tablet or non-Apple product tablet. This way I could also strengthen my conclusion that Apple products emit color stronger or emit color better than non-Apple products. And finally, I would like to test if there's a difference between different types of display settings and modes. This includes different brightness levels, and also I'm curious about the night mode to see how much that affects the output of color on screen, and also how much it lowers the color on screen. References, this is the references for my information with the project. And finally, I would like to give a special thanks to my instructors, Mayvon and Catherine. I would also like to thank my peer mentors, Mia Fong, Anthony Lopez, and Leo Tanaka. And finally, I would like to thank the entire HONCC and the PEEC2 program. Mahalo. Thank you.